back, guys. Today we will be solving a new problem. The problem name is nearly sorted, and we'll go through to the problem description and then I'll code it along with you guys. Okay. So let's read the problem statement first. Given an array ARR where each element is at most k away from its target position, you need to sort the array optimally. Note, you need to change the given array ARR in place. Okay. So we have been given array, and from this array we'll have to get the sorted array. It may sound a bit easy, like we can definitely use the sorting algorithms that we are provided have been provided by Java, that you can just simply use them and the problem would be solved. But that won't be the most optimal way of solving this problem. In this question, it is specifically mentioned that each element is at most k position away from its target position. Like for an example, if you see over here in the array 6, 5, 3, 2, 8, 10, and 9, obviously this is not sorted. If we look at the correct position after after sorting this array, 6 is exactly 3 position away from its uh, initial position. Similarly, 5 is just 1 position away from its position. So the idea is basically that the element should be placed at most k position away from its target position, not more than that. In this case, k is 3, and we'll have to solve it particularly like that only. So the approach that comes to my mind for solving this problem is basically using heaps. Using heaps, we can solve this problem like the previous problems which we solved. It would be more or less same only, I guess. I am thinking that first I'll make an array list, and I'll just start putting the elements of the array. I'll create a heap as well, a priority queue as well, minimum min heap, and I'll just put it into the min heap. And once there is k element or more than k element, basically k plus 1 elements in the heap, I'll check. I'll just put the smallest element from the heap, that ones that would where that would come out from pq dot from priority queue dot remove. Once one that element would come out, I'll just put it into the list, and that way I'll continue it until the priority queue is empty. Once it is empty, my whole array would have been sorted and it would be just placed into the list. And then what I'll do is, from the list I'll just one after the other place override the array. That way our problem should be solved. Let's see whether the thinking procedure is correct or not. Let's see. Now we'll type it out. So uh first first we'll make a priority queue. mm, Integer pq new priority queue. And once we have this priority queue, I'll also have to make a list. So list integer, let's call it ans equal to new array list. Now I'll take a loop control variable I and set it as 0. Now I'll run a loop while I is not equal to arr.length. I'll just simply add the element from the array over here first, and then I'll check whether the size of this priority queue is greater than k. If it is so, I'll just do one thing. I'll just add into the answer and remove the element which has been removed from the priority queue. I'll just add that into the list, and this would result. I'll just write a comment over here. This would result in me getting a sorted array into my list. But the thing over here is, the we won't get the whole array. We will still have some elements, to be precise k elements still present into the priority queue. So what I'll do, I'll write another condition over here. While PQ dot size is greater than 0, I'll just repeat this procedure of over here. Now it is completely sorted. So right now it is completely sorted. Sorted. And now once we have done that, I'll set I as 0 again, and again run while I is not equal to this time ans dot length. Both lengths are same, answer size rather. Just a minute. Yeah. And then what I'll do is that I'll set AR of I as ans dot get I plus plus. I hope this should run. Let's see whether it is running or not. Mm, yeah, the test case has been passed. Let's submit it. Lovely. So this has been solved. Thank you guys for watching the video. Do like and share. Thank you.